Today's video will be a proof of this equation, that is sigma 1 by k square as k tends from k is equal to 0 to k infinity, which can be simplified as this: 1 plus 1 by 4 plus 1 by 9 plus 1 by 16. So the denominators are the squares of natural numbers ranging from 1 to infinity. Let's start off this proof with a simple logic that if we have a polynomial or a quadratic equation whose roots are alpha and beta, then that polynomial can be written as some constant c into x minus alpha into x minus beta. If we have a cubic equation which has three roots, alpha, beta and gamma, then that cubic can be written as some constant into x minus alpha into x minus beta into x minus gamma. Now, if we have the graph of y is equal to sin x, which goes on like this, may not be true to the scale but looks roughly just like this. Now, the graph of y is equal to sin x cuts the x axis at x equal to 0, plus pi, minus pi, plus 2 pi, minus 2 pi, and so on. So, the general solution of the y is equal to sin x can be written as x equal to plus minus n pi, where n can be any number ranging from 0 and goes on till infinity. In this way, sin x can be written as a polynomial, that is x some constant into x minus 0 into x minus pi into x minus 2 pi and so on till infinity, and also the negative values of x, that is x plus pi, x plus 2 pi, so on till infinity. Now this can be written as, we have the identity that a plus b into a minus b is equal to a square minus b square. So we can group these two terms together, that is x minus pi into x plus pi, which can be written as x square minus pi square. Writing x minus 0 as it is, x minus 0. Grouping these two terms together, we get x square minus pi square. These two terms together, we get x square minus 4 pi square. The next term will be x square minus 9 pi square and x square minus 16 pi square, and so on till infinity. Now, how do we find the value of this constant? Since this sequence is till infinity, we might apply a limit here, but we don't have a limit for sin x tending to infinity, though we have a limit for sin x by x. So we have one x right here, so we can divide both sides by x. Sin x by x equal to some constant c into x square minus pi square into x square minus 4 pi square, x square minus 9 pi square, so on till infinity. I have to find the value of the constant c, and I have written it, I have divided both the equation by x as proved earlier. Now applying the limit x tends to 0 on both the sides. When limit x tends to 0, sin x by x, this is a typical limit which gives the value as 1, and applying limit on the RHS, since there is nothing in the denominator, we just put in the value of x as 0. RHS is equal to the constant c into minus pi square into minus 4 pi square into minus 9 pi square, so on till infinity. And these two are equal, so the constant c can be written as 1 by pi square in minus pi square into minus 4 pi square into minus 9 pi square, so on till infinity. Putting in the value of the constant c here, we get that sin x by x is equal to minus pi square. So 1 by minus pi square minus 4 pi square minus 9 pi square, so on till infinity, and these terms, that is x square minus pi square, x square minus 4 pi square, x square minus 9 pi square, so on till infinity. Now we can put these terms into the respective brackets to simplify each of these terms, that is sin x by x, putting in minus pi square into the first bracket, that is dividing by minus pi square into this, we get that uh, x square by minus pi square minus pi square upon minus pi square. So this will be coming out as 1 minus x square by pi square. The next term would be 1 minus x square by 4 pi square. And so on. The next will be 16 pi square. Next further term will be x square minus 25 pi square. So this goes on till infinity. We had gotten this result before. Now we also have a Taylor series for sin x, that is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial, and so on till infinity. If we divide by x on both the sides, we get sin x by x equal to 1 minus x square by 3 factorial. From here we get x power 4 by 5 factorial minus x power 6 by 7 factorial, and so on till infinity. Since sin x is the same in both of these equations, we will get that RHS of both the equations are equal. So writing it as 1 minus x square upon pi square into 1 minus x square by 4 pi square, 1 minus x square by 9 pi square, so on till infinity is equal to 1 minus x square by 3 factorial plus x power 4 by 5 factorial, so on till infinity. Now if we observe in this, the left hand side, if we take out the coefficient of x square, we will get something in the form of this sequence. So to find the coefficient of x square, we will take out one of these terms from one of the term of x square by pi square from one term and multiply it with one from the all other terms. Like if we, to find the coefficient of x square, this into 1 into 1 into 1 from all the other terms. If we multiply this with any of the other terms, that is if we multiply this with this, then we would get x power 4 upon 4 pi power 4. But we need the coefficient of x square. So multiplying this with all the other ones, we get that x square by pi square. Multiplying this with 1, 1, 1, 1. We are simply choosing one of the term from the infinity terms possible. The next term would be minus x square by 9 pi square. Next would be minus x square by 16 pi square, and so on till infinity. And since we are observing only the coefficient of x square, we can write this as minus x square by 3 factorial. Taking minus x square common or equating directly the coefficient of x square, we get minus 1 by pi square into 1 by 1 plus 1 by 4 plus 1 by 9 plus 1 by 16, so on till infinity, is equal to minus 1 by 3 factorial, which is 6. If we cut minus on both the sides, we will get that 1 plus 1 by 4 plus 1 by 9, so on till infinity, is equal to pi square by 6, as we multiplied pi square on both sides.